Today we're going to talk about the game of Blackjack. We're going to actually show you the rules of Blackjack, and then we're going to talk about how you would take a game like Blackjack and turn it into an object-oriented program. Specifically, we're going to look at the different types that you would need to implement and think about why you would want to implement those types. Now, I want to stress there's no perfect way of doing this. Like all programming, it's an art, not a science. So you have to sort of think about the design decisions you're going to make. And because of this, we're going to actually show you why we're picking things. And so I'm going to tell you why, and in fact, Joe is also going to tell you why. So hopefully by getting the different perspectives and seeing one way of designing this program, you're going to get some insight in how we think about object-oriented programs. Now, first, you have to understand the rules of Blackjack and the game of Blackjack before we can actually discuss how you're going to implement Blackjack. So, let's play some Blackjack.
Okay, welcome to class. In week 6, we're going to build the computer implementation of the card game Blackjack. So Blackjack is a gambling game that's played in Las Vegas. It uses a standard deck of cards, or a non-standard deck of cards, as we have here with the ones that John provided us. It's a game where a player plays against a dealer. The dealer usually represents the casino. The object of the game is to get a hand of cards whose value sums up to as close as 21 without going over. So let's just play a hand here, and we'll kind of go through the mechanics of the game. So what I'm going to do is I'm going to deal out a card to Scott. I'm going to deal out a card face down to me. I'm going to deal out a card out to Scott face up. I'm going to deal a card to me face up. And the way the game works is Scott gets to go first. And he has two options. He can either stand or hit. Hitting requires me to give him another card. The cards have values. Face cards have value 10. Numerical cards have their numerical value. And then the aces have a special value. They can be chosen to either be 1 or 11 at the player's option. So at this point, Scott's got to finish drawing all of his cards hitting, and he can stand at any point. If he goes over 21, he busts and immediately loses the hand. Then at that point, I'll go through and I play my hand. And as dealer, I have no choice in how I play it. I always hit if I have a value less than 17, and I always stand if I have a value greater than 17. So I think at this point, we're ready to go ahead. So Scott?
All right, so if I was really playing this is 11 plus 7, 18, I'd probably stand, but just to demonstrate here, I'll hit. And I have 21, so I'm going to stand.
Why aren't you in Las Vegas right now? All right,
Yeah.
so I'm going to turn my card over, and I have a 14. Lucky me. So let's see. I'm going to have to get a 7 or automatically lose the hand. So I have a queen. So my hand now is 14 plus 10 is 24. So I busted. So Scott wins.
Where's my money, Joe?
Oh, man, we forgot to set the bet again. So those are the rules of Blackjack. We'll come back in a little while and we'll actually play a game for some higher stakes instead of a very nice bet.
So you just saw a game of Blackjack, and hopefully now you have a feel for the rules. I also probably have a little bit of credibility, right? I now won a game of Blackjack. I want to point that out yet again. And I also want to point out one more thing before we get started here. Notice how I won and Joe didn't pay up? I want you to keep that in mind as you watch some future videos. Anyway, so how do we implement Blackjack? We're going to implement this as an object-oriented program, and the first part of the design process for any object-oriented program is to think about what new types I'm going to need. So what do I need to implement the game of Blackjack? Well, I'm going to argue that I need a card of some sort. I need a hand to represent both the dealer's hand and the player's hand, and I need a deck of cards. And I think this is pretty much all that we need, right? These are the physical objects that occur in the game of Blackjack, and so they're going to have analogs inside of our program. So let's talk about what these types actually are. So what's a card? Well, a card can be represented as a rank and a suit. So the ace of spades. All right, and you probably also want an image associated with the card. That's what I'm going to draw on the screen when I actually have that card. All right, so that's all there is to a card, really. Hand, what is a hand? Well, I'd argue that a hand is simply a collection of cards. And what is a deck? Well, a deck is also a collection of cards. Now, If I look at these data types, I might think, well, there's really only two types, right? There's a thing that's a rank and a suit and an image, and then there's a thing that's a collection of cards. But this is not all there is to defining a type. Okay? A type is both the data that is encapsulated inside that type and the behaviors that you can perform on that data. So what can I do with a card? I can't really do much with a card. Maybe I could rip the card. Of course, I'd probably get thrown out of the casino if I go around ripping cards. So really probably the only behaviors of a card is I can look at the rank, I can look at the suit, and I can draw the image. So it's not that interesting. What about a hand? What can I do with a hand? Well, a hand has more interesting behaviors. I can perhaps hit, right? Add a card to the hand. I could score the hand, figure out what it's worth, right? Maybe it's worth 21, and I know that I don't need to hit anymore. Okay, so I need these behaviors at least. What about a deck? What can I do with a deck? Well, I would argue that you can shuffle a deck. You can deal a card, right? When a player hits or when you deal in the beginning. Okay, so now it becomes a little more obvious that there are three different types here. I have the card, which I think we've discussed, and then I have a hand and a deck, both of which are collections of cards, but both of which have different behaviors. It doesn't make sense to shuffle a hand or deal a hand, and it doesn't make sense to hit the deck or to score the deck. Okay, so I have independent behaviors. So with that, we have three different types that we're going to want to implement for our blackjack card game. They each have different behaviors associated with them. And so now we're well on our way to designing our blackjack card game.
Well, Scott's kind of walked you through an introduction to the classes for Blackjack. So what I'd like to do is provide a little perspective as somebody who's not as an experienced programmer in terms of object-oriented design to kind of give you my insight as the rationale behind why we should learn more about OO design. So I've programmed for a long time. I've been programming for 30 years in C and C# and a lot in Mathematica. But one of the things about the way I build code is I typically build code for myself, or I might work with another student. So the practices that I follow as a programmer are not necessarily those that are optimal for working in larger projects. So what I'm going to do is I'm going to talk a little bit about my experiences in building the Blackjack project and some of the discussions that Scott and I had concerning how to design an appropriate class structure for Blackjack. About 3 months ago, as Scott got Code Sculptor online, I sat down and started implementing Blackjack. And so my first implementations were short and sweet. My goal was to keep the number of lines small and have it produce a nice game. Scott's been looking over my code, thinking about it from an OO's point of view, and he's noted that some of the design decisions that I made in terms of how I set up classes in here probably weren't optimal. But what does it mean for them not to be optimal? In OO design, one of the primary objectives is to facilitate code reuse. If you build your OO design correctly, you can take the code that you built, you can pull it out and use it in some other project. So for example, in Blackjack, I built a hand class, I built a card class. Now the card class was, I had a rank and a suit, but I also included a value field. And Scott pointed out, well, cards really don't have a value field. They don't have a value from 1 to 11. If you want to build a card class that's going to be able to be used in other card games, you should really not put that in there. For example, I want to use it in poker. Well, poker doesn't have a value. So he suggested that I pull that value computation back into a hand class and think of it as a hand class for Blackjack, a Blackjack hand. Now that's the place where I can place computations about the value of the hand. I also implemented a deck as a list of cards and built an algorithm that shuffled them and dealt them out, things like that. And again, Scott pointed out that probably a better design decision there would to build a deck class that would create decks of cards and have methods, things like shuffle and deal and things like that allow you to abstractly interact with the class. That would allow you to use these methods, again, this has something like a poker game. In fact, this whole idea of abstraction, that what you do is you separate how the object is implemented versus how you interact with it, the methods, is kind of a nice idea. It allows you, when you're building your code, to hide the details that others may not need to know.
how I implement a deck. Well, it's not so important. As long as I have a correct class of methods for you to work with, I can just not even tell you how I implemented a deck of cards. So those are a couple of observations about how object-oriented design should work.
So we've talked a lot about Blackjack now and how you might build an object-oriented version, or rather how you might design an object-oriented version of the game. I just wanted to briefly show you some code. We're gonna walk over this again when we do the mini project run through, but just for now, to finish up this video, right? Here's my hand class. Here's my deck class. Okay, so you can see I have class hand, and then I have a bunch of methods. I have an initializer. I can turn it into a string. I could add a card to a hand. I could get the value of a hand. I could check if the hand is busted, if I have over 21. And I can actually draw it on the canvas. Similarly, I have a deck. I have an initializer. I could shuffle, I could deal. Okay, and I need a third class, a card. Okay, so I think this should be straightforward after having seen the lectures on object-oriented programming. Then we talked about the 3 different classes that you might want, and I just wanted to show you, hey, here's what a piece of code might look like. Again, we're going to spend more time on this when we describe the mini project.